Let's get started with Chapter 2, Solving Linear Inequalities. This is Section 2.1, where we are writing and graphing inequalities. So you've probably seen these things before when things aren't equal, but they're unequal or inequalities. It's to show that one number is more than or less than another number. And we can graph them, we can solve things with them. Shading's usually involved because you're not going to have just one answer. You're going to have a large group of answers, or everything greater than this number or less than that number is true. So let's get started with that. So when we're looking at these inequalities, so you have, as we read this, x is less than 2. So if you have the small part of the inequality sign, that thing is less than. I could also read it from this side, 2 is greater than x, because as I'm reading, the larger part is what comes first. So I can read x is less than 2, or 2 is greater than x. So when I'm down to something like that, and it's just one number there, I know I'm going to have a cutoff point at that number, at that 2. And so I'm going to put an open circle on the 2, and then I want to show all the values that are less than 2, because this x is less than 2. So I'd want to show that 1 and 0 and -1 and -2, all those numbers would be less than 2. And so I want all of these numbers to be true. And if all of these work in my inequality, then I'm going to shade that side. And what that means is any number that's less than 2, that's to this side of 2, all fit into this inequality. So if I took -5 and put it there, yep, -5 is less than 2. If I took 0 and put it there, yep, 0 is less than 2. What about if I took 2? Is 2 less than 2? No, it's not. 2 is 2. It's not less than 2. It's the exact same. So that's where we come to this one. This sign is almost the same, but it's almost like a less than and an equal sign had a baby, and it was this. It was less than or equal to. So that's almost the same thing, except it also includes the 2. It's saying, yeah, all that stuff from before, but we're also going to add in the number 2. That also is going to make this true. And then as we go the other way, with our next problem, we've got x is greater than 2. So the larger part's open to my x there. So x is greater than 2. So I want to open circle on the 2 because the 2 is not included. And I want to show all these numbers here. They're all true. All that are to the right of 2. And then my last one, it's kind of the same as before. It's just like that greater than 2, except it also includes the 2, because that's greater than or equal to 2. So that's just how we graph all of these inequalities, just how you show those. When you're wanting to graph, zero in on the variable. The variable is what you're shading. You're showing what the variable is. So even if I had, 2 and like this, so something like this, I'm going to read it from that right side. I want to say x is greater than or equal to 2. So I want to shade the numbers that are greater than or equal to 2. So that would be this bottom one down here. It would be that one. Okay, so just be careful when they switch up where the variable is on you. Just read it from the variable side. Okay, so the next type of question we're going to have is this a solution? And on this one, I've got 3 different possibilities. You know what? I didn't add in, let's see, less than 3. So we've got this inequality here. 6 over x is less than 3. And we've got three possibilities. What about when x equals 1? What about when x equals 2? What about when x equals 5? We're going to try each one out and say yes or no. It is or is not a solution. So let's try the first one. When I want to decide if something's a solution or not, we substitute in that number. So first I'm going to take 1 and substitute it in and work out that left side. So I end up with 6 is less than 3. And the question is that true? Is 6 less than 3? Well, no, 6 is not less than 3. So no, it's not a solution. Let's go to the next one. 6 over x is less than 3. 6 over 2 is less than 3. 6 over 2 is 3 is less than 3. Is that true? No, it's not. No, 3 is not less than 3. 3 is equal to 3. But if we added if we added this sign here, then yes, that would have been a solution, but it was not on there, so no, it's not a solution. And our last one is 5. 6 over x is less than 3. 6 over 5 is less than 3. And so 6 over 5, it's like 1 something, right? 1 and a little bit more, 1 and 2/10, because it'd be an extra 1/5, which would be 0.2, or I could have written 1 and 1/5. So is 1.2 less than 3? Yes, it is. $1.20 is less than $3. So my answer is yes, that is a solution. Okay, so that's what we do when it asks, is this a solution? Last type of problem. That's a lot of writing. We are going to translate this over into math terms. So instead of having equal signs on these, we're going to have greater than, less than, greater than or equal to, less than or equal to signs. 3 is more than a number. So this phrase is more is, that's what we're going to use for greater than, is more than a number. So 3 is greater than x. That's all we do there. Now be careful, because if it said 3 more than a number, well, then we're talking about 3 plus x. But is more, is, remember before, we would say that's, where did I go here? Is the equal sign. We put an equal sign for an is. But now if it's is more, that's something that tells us, okay, you're going to have a greater than sign. Same way, is less than, so that's going to be 3 is less than a number. So very similar problems there. Let's get into some trickier stuff. 3 is no more than the quotient of 5 and a number. Okay, well, I know I'm going to start off with 3, right? We can at least throw a 3 in here. So if it's no more than, it'd have to be less than, right? It's no more than. Could it be equal to also, though? Well, yeah, that would be no more than. It could be equal to that as long as it's not more than. So that's going to be less than or equal to. The quotient, okay, quotient, that means divide. So I'm going to put a little division line there. 5 and a number. So 5 on top, x on bottom. So the next one, 3 is no less than. So that, if no more than is less than or equal to, no less than would be greater than or equal to. Okay, and the sum of 2 and a number. So when it says the sum of, I know I'm going to add some things together. 2 and a number. So next one here. 3 is at most 6 less than a number. Okay, so if something's at most, let's say you're at the store and folks say we can spend at most $30 on this shirt or whatever it is you're buying. So at most, it's not greater than. You're saying it's got to be less than or equal to. 3 is at most 6 less than a number. So I'm going to pause a second on this at most, because when you say at most, you're kind of setting a ceiling. You're saying this is the highest point. And so 3 is less than or equal to. And now 6 less than a number. So be careful with that too, because this less than can be tricky. You almost think, oh, 6 minus x. No, be careful. Careful. If it's 6 less than something, that means you're subtracting 6 from that thing. If I said, you're 12 years less than someone else, 12 years old less than someone else, you would subtract 12 from their age. So same way, 6 less than something, less than a number, we're going to do x minus 6. All right, so the last one, 3 is at least, so that means greater than or equal to 6 less than a number. Again, that's x minus 6. So in the same way, at least, it's saying it's got to be greater than or equal to. You're setting a floor in. You're saying, okay, it's got to be this much or more. Okay? That is all I've got for 3.1. Good luck on your homework, kids. Do well.